Yes. Hey everyone, welcome to this live stream. I am Aniket Maurya, a developer advocate at Lightning AI.
And I'm Josh Starmer, a lead AI educator at Lightning AI.
Awesome. So, in this live stream, we are going to talk about how you can build a machine learning pipeline like Lego games. So, let's get started.
Hooray! Let's do it.
Yes. So, before we start, we would like to hear from you. So, this is a QR code which you can scan or go to the URL mentioned here to fill up a feedback form. You can submit what would you like to see more from us, and we will make sure to happen that. And what would you learn after the end of this live stream? You'd learn how you can train a scikit-learn model on cloud and how you can use Lightning AI platform to build machine learning pipelines on cloud. You can connect all these machine learning components and build a big platform, big um, machine learning pipeline for yourself. So, why this Lego theme? If you're wondering, we have these small little Lego games, Lego plastic pieces, which anyone can connect together to build something really big. For an example, you can build an airplane just from these little plastic components. Here, we have some components of machine learning components like training component, model store, model serving, monitoring. All these components can be connected together to build something big. We have built a whole machine learning pipeline just by connecting all these components. Isn't that cool? And
Very
with
cool.
Lightning Framework, yes. And with the Lightning Framework, you can connect everything to build a platform for yourself. So let's get started with building a machine learning component. And we are going to use Scikit-Learn to train our model. And then we use the same code, training code, to convert that into a Lightning application. So I am going to use a Jupyter notebook. I will show you how to train a decision tree classifier. And then I will use the same code to turn that into a Lightning application and train that on cloud.
Very cool.
Yes, and you must have heard about this very famous data set called iris flower classification dataset. And you can see these are the three flowers, iris setosa, virginica, and versicolor. And the data set of the features of this data sets are the petal width, petal length, sepal width, and sepal length. We are going to use these four features to classify the flowers into these three classes.
Cool.
And first of all, we will import all these libraries and all these functions, which is going to make our life easier. Let's run this.
Can you tell us what those libraries do or modules do?
Oh, yes. So first we import load iris. It is a function which scikit-learn provide us to load the iris dataset. So it has made our lives easier. Then this is a tree module. This tree module defines various tree algorithms like decision tree, random forest, etc. And then we have train test split. So whenever you are training a machine learning model, it is usually a good practice to split your data set into training and test set so that you can evaluate your model and you can check whether your model is overfitting or underfitting. Finally, we have imported something called matplotlib. It is a very useful library in data science that you can use to plot different kinds of charts and histograms, etc.
Cool.
Let's let's load the data set. And our dataset contains 150 rows and 4 columns. That means 150 different collection of flowers. I have printed some of the classes, which are three Setosa, Versicolor, and Virginica, and these are our features name.
Okay.
And before we go further, I'm going to make sure that in this tutorial, we are not going to focus on like learning decision tree. The aim is to learn how to train the machine learning model on cloud. So if you want to learn the internals of decision tree, Josh has a great YouTube video tutorial. You can go to his channel StatQuest and check that out.
Cool. Bam.
Bam. Let's plot our flower dataset.
Before we do that, can you actually go through the code that we use to plot it? Because it looks like there's a for loop or something. Um,
Yes. So this is our code for plotting the data set. So what I have done here is I have iterated through all the data.
mhm,
I have separated the, I think I have, yeah, I have separated petal width and petal length,
mhm.
and I have plotted them on these two axes. So you can see here, I have iterated through all the target names, which are Setiusa, versicolor, and Virginica. I have extracted respective petal width, petal length, and then use the matplotlib scatter to plot these data.
Cool,
Finally, just some cool stuff to show the label in x-axis, y-axis, and the title in the chart. And here
cool.
it is. It is very easy to visualize your data set. It is an easier data set, so you can clearly see this blue concentrated color points here are belongs to the setosa flowers, then these orange points belong to the versicolor, and then the green points belong to virginica. Now let's split our data set into training and test set. Then we build our model from the decision tree classifier class, and finally we train our model with the training data set. Let's run the cell, and we have achieved 97% accuracy on test data set.
It's great. Hooray. That's awesome.
Yeah. And one really cool thing that Scikit-Learn provides is you can plot your decision tree. So decision tree has been plotted with this tree.plotTree module. And here I have just provided the classifier that I just trained. And here it is. It might not be much clear, I guess, but let me zoom in a bit. Cool. So you can visualize how your model is going to make that a particular decision. So you can see if the petal length is less than equal to 2.6 centimeter, it goes into the left node, and you can see it belongs to class Setosa. And you can confirm that from the chart you just plotted above.
Right
So
there.
yes, so if we see petal length is less than 2.6, all points from Setosa is concentrated here. So it is very easy to visualize all these things with scikit-learn.
Very cool.
Hooray. Now we have
Hooray.
trained
Yeah.
our, yeah, now we have trained our machine learning model. So
Yeah.
what next? We are going to use the same code to turn that into a machine learning application. Lightning AI framework provides us a very easy and useful way where you can train this model on cloud. So let me go to my VS Code here.
So, so Aniket, what you're saying is like we just started off with a really tiny data set, and that's fine for running on our laptop. But if we had a
Yes.
really huge data set, we might want to do that in the cloud. And so now you're going to show us sort of like what we need to do if we're going to use Lightning, what we need to do that, like what things we need to change and to make it work. Is that with a plan?
Yes. So when you have a very small data set, it is easier to train on a small device like your laptop, which usually have lesser RAM. But suppose if you have terabytes of data and if you want to process that, you cannot really do on your laptop. So with Lightning AI framework, you can basically you can code everything on your laptop. You can run that on your laptop, and once you are ready, with just a simple command, you can push whole code to cloud platform, and your code will be executed in the cloud. So I'm just going to show everything how you can take the same code, turn that into a Lightning application, and deploy on cloud.
Cool. Oh, so this isn't,
Bam.
we're not just going to run it in the cloud. We're going to deploy it in the cloud. This is going to be, we're going to create an app so that it has an interface, a user interface, and it's got a front end. And this is, we're not just like training something in the cloud. We're training and then we're deploying. We're doing like a whole pipeline worth of stuff, it sounds like.
Yes. So, like we said, like a Lego, we are first
Mm-hmm.
going to build a model training component, then we will build a model deployment component. We will
Cool.
connect these to make a machine learning pipeline and deploy the whole pipeline on cloud.
I
Once the
love it.
pipeline is deployed, you can see the UI on cloud. You can share that link with your friends, your colleagues. They can open it, try your application right there in their mobile browser, their desktop, anywhere.
I can't wait.
So As you can see here, these are just the same import statements, and one difference here is I have imported Lightning, and I have imported this just so that I can use some very cool stuff like I'm going to show you here. So first, I have created a class called Scikit-Learn training, which inherits from Lightning work. Lightning work is a building block for running long works. For example, a model training task, model deployment, downloading a very big data set, which is any kind of work that is going to take a long amount of time. We can use Lightning work to execute it.
Okay.
So our model training might take a very long time. That's why I have used Lightning work.
Okay. In this
Then
case,
you
it
see,
in this case it
yeah,
won't take very long because we've got such a small data set. But in practice, if it's like a real data set, we might spend a lot of time downloading it or installing that data set, and then we might spend a lot of time training on it. Is that
yeah,
more
exactly.
more realistic? Okay, cool.
Yes. So in real scenario, you can just replace your data loading part, and if you are training a different model, you can replace that. And in fact, you can build a different separate component for data processing. For example, if you are downloading the data set from a BigQuery table or something, which usually has very large amount of data, you
Mm-hmm.
can build a separate component and connect that here.
Oh, cool.
So I'm going to show that later once we have built our training component and the deployment component. I'm going to show how you can connect those two to build a pipeline.
Very
So
cool.
yeah. So let's see what is here. We define the init method, and here we have passed something called cloud compute. What is
Okay.
that? And here I am training a scikit-learn model. Suppose if I had a deep learning PyTorch model, I would need a GPU so that I can train my model faster. So here you can specify different kinds of machines. So you can specify CPU, CPU small, your GPU type, for instance, T4 or A10, and you can also specify disk sizes. So I don't need a very large disk. For example, I have entered 10 here, so it will be 10 gigabytes of hard disk for my application.
Yeah. Which should be plenty for our 150 row data set.
Yeah, more than enough.
Hopefully.
And then we have something called a drive. This drive is a persistable storage object. So once we have trained our model, we need to store it somewhere so that we can use it later for deployment, or maybe download it and then use it on our local system or somewhere else. So this drive is a shared storage which we are going to use to save our model. So we have created a model storage object, and then we have defined a function called run. So this method is exact place where we define all the stuff that is going to run when we start our application.
Okay.
So you can see here, all the model training part exists in the run method. Download the dataset, training test split, initializing the model, training the model, checking accuracy. And here we have some additional steps like we dump our trained model into the disk first, and then once the model is dumped into our disk, we are going to copy that into the shared drive using this drive API. So what we have done is self.modelstorage.put. It will take the file from the file system and put that in the shared drive, which we are going to use later.
Hmm. So what you're saying is, in terms of downloading the data and training the model, we're doing exactly what we did before. The only difference now is that we are going to save the model. We're going to write it to a file, and we're going to move that to some persistable storage place so that we can use it later.
Yes, exactly.
Very cool.
And to run this component, we just need to initialize this class and then create a Lightning app from our imported Lightning library. Just pass this inside the Lightning app. Then we can open our terminal and run this cool command, which is Lightning run app, and our file name, which is app.py. So if you just enter the command here, it will launch this application on your laptop. If you
Okay.
want to launch this application on the cloud, you need to add this flag call double hyphen cloud. You can even name this application. So let me name this as live stream and then press enter.
I love
So
I love that all we had to do to launch this into the cloud was just put dash dash cloud. I love
yes,
that.
that is very handy and cool.
Yeah,
As a machine learning engineer, one doesn't need to learn S3, AWS, anything. They can just get started. So that's really
super
helpful.
cool.
So let me open my dashboard. Here I have a new application, which is, let me
And
see the
th-
logs.
this dashboard. So, can you just tell us how you got here? I mean, you pulled up a web browser, and um,
Yes.
how?
So I have already logged into Lightning AI, but if you
Okay.
haven't, you need
Yeah.
to go to lightning.ai,
Uh huh.
then you need to first sign up for the platform.
Okay.
If you sign up, you also get 3 credits for yourself. So
Okay.
you can use that to run any machine learning application, deploy anything for free.
Yeah. Very
So
cool.
once
So we can try all this out. No, there's not going to be any cost. We just sign up. We get 3 free credits, and then we can log into this dashboard that you've got right here. So it's pretty
yes,
straightforward.
yeah, exactly. And I am using my free Lightning credits to run this application
Cool.
right now. So in the logs, you can see I have a work here, and my work is basically the Scikit-Learn training component. If I expand this, I can see I get the same test accuracy which I received in the Jupyter notebook, which is 97%. So
Very
we can
cool.
verify that we didn't make any mistake and we are ready to go.
So, Aniket, I hate to make you do this, but is there any way you can zoom in on
Oh,
this window a little
yes.
bit,
Yeah,
just so we
really
can see
sorry
the
about
fonts a
that.
little better? So we see that at the work. So the very first thing, there's a checkbox that says "Wait for machine availability." So I guess we didn't have to wait very long, which was awesome. And then it installs things for us. Did you create that requirements.txt file, or is that a standard thing? Or
Yes.
uh
So suppose if you have an application and you need a lot of different Python dependencies, what you can
huh.
do is you can define this file here, requirement.txt, which is usually what we do. And here I have defined like some requirements like I need scikit-learn, I need this radio library, fast API, and lightning
Okay.
like API access. So you
Okay.
can define all the things that you need to run an application in this requirement.txt, and Lightning will make sure to install all of these for you.
Aniket also, there's another person in India named Aniket who asks, what is the difference between dump and model storage dot put? Aren't they doing the same
Yes,
thing?
that's a great question actually. So the dump here is, if you see, I have imported it from job.live. So the
Mm-hmm.
task of this dump is, I have my decision tree classifier created here. CLF
Mm-hmm.
is equal to my decision tree classifier. It is a Python object. So I need to serialize it on a file system so that I can copy it to somewhere else and load it from a different Python interpreter. Joblib is used to do the same thing. So I have serialized this on my file system.
Okay.
But so once I have trained my model, I do not need this machine anymore. So I'm going to stop that machine. And once I stop that machine, my file system associated with that machine, basically my hard disk for that machine, will also stop, and I won't have any longer access to the my machine learning model. So this thing here, this drive thing here, is a provides an API like put, get for retrieving, put for copying. So what it has done here is it took my model on my current file system and pushed it to a shared drive, which I can use later.
Okay. So
So let
it,
me,
so in a nutshell, what dump does is it creates a file out of our whatever we did in scikit-learn or whatever our model is. Dump creates the file, and then the model underscore storage dot put. What that does is it puts that file somewhere that's not going to get blown away once we turn off that cloud computer that we've been using before. It puts it somewhere that's persistent, and we can call on it later. Was that a good summary?
Yes, exactly. So if you see, actually you can access that model in the UI here.
Okay,
So you
cool.
can come to the UI, click on artifact,
Uh
and
huh.
here you can see I have
Oh,
my
there it
model
is.
dot job. Yes.
Bam.
Yeah. Hooray.
Yeah, that's awesome. Okay, cool.
Cool.
So going back, so I'm sorry for the interruption. I feel like I'm responsible for it all. But so going back, so you did that command line where we ran the program and we put dash dash cloud, and then we were able to go to our dashboard and we saw that we'd started up a machine and that we'd configured it according to our requirements.txt file. And then what was the next step? Can we go through the remaining steps of that process?
Yes. Did you mean the remaining process for uploading it to the to Lightning platform?
No, because what you'd done is you'd gone to the dashboard. Yeah, sorry, this is so
Ah,
confusing, but you'd gone to the dashboard and there was these four or five check boxes.
oh,
Y-
this one.
yeah, no. You clicked on not that one. Click on what was the one we just did? We
Okay.
did artifacts, but we went to. I thought we had like a list of like there was a purple checkbox and it said starting up, looking for a server.
Ah,
And
okay.
then, yeah, okay. And then it said install dependencies for requirement.txt. And then we hadn't talked about the next step, the run
Yes.
initialization. So can you talk about that?
Yeah. So So first of all, what Lightning does is it creates your machine. I have a CPU machine, so it
Yeah.
creates a CPU machine for me. Install if I have any requirements,
Uh-huh.
and then suppose usually in Python projects we have something called setup.py, which defines certain aspects of the project. It sometimes you can also insert your requirement dependency and some other scripts which you want to be executed while installing your repository.
Can
So
can you talk about the one for this project specifically? Like what did you have to do for this project?
So for this particular project, this was a very simple script. So I didn't
Uh-huh.
need any setup.py and
Okay.
I didn't create one. So
Okay.
Lightning just ignores and like you do not have a setup.py. So it just
Awesome.
ignores and move to the next step.
So if we don't have one, it's no big deal. It's just
Yeah.
if we've got a really complicated project, sure, we might have something called setup.py. But if we're just starting out, we're doing something super simple, we don't have to worry about that.
Yeah, exactly.
Cool.
So you can basically just start from a single Python file like app.py. You can
Uh-huh.
define everything there. And even there is a very cool function in the framework.
Mm-hmm.
So if you just have a single dependency, for example, scikit-learn, you
Uh-huh.
can create this hash rank, like you can
Mm-hmm.
create this comment
Mm-hmm.
and then just enter pip install scikit-learn and it
Mm-hmm.
will install that for you.
Oh, very cool.
So
So if you do have complicated packages or whatever that you need to have, you can put that in the setup.py. Can you put that in the requirements.txt?
yes, so you can put that in requirement.txt, but if it is very like just a single library, why
Mm-hmm.
would you create a new file?
Yeah. So we can skip that. We can just put it right directly into our code.
Yeah,
I love it. Bam. So go.
bam.
Exactly. Cool. Yeah.
And so for installing this, you need this command, like
Yeah.
lightning run app,
Yeah.
app.py. You need to add this double hyphen setup. So it will install this for you.
Okay.
And the usual stuff, double hyphen cloud. And if you want to name something, if you do not name, Lightning will automatically name a very, like automatically choose a very cool name for you.
That's awesome. What are now you got me like wondering about all these cool names. Like
Yeah,
file number one.
no, it's so I, I think it chooses a very like creative name. So you should definitely try it out like without a file name.
Okay.
So it will create a very cool name for you.
Okay. I'm looking forward to the cool file names. um,
Yes.
uh, I think we have a question, but I kind of want to save it for the end because someone wants to know how this framework is different from Airflow. And what I think we should do is maybe we should just go through and just see how everything works, and then we could talk about that at the end. Is that okay?
Yeah.
Okay, let's keep
Yes.
going.
Cool. So once we have trained our model, what
Yeah.
next? We need to deploy it so that we can expose it to some other person who can use our trained model. For example, if someone trains a fraud detection model, someone else might in their company might need to use this that as an API to classify if the comment request is a fraud or not. So what I'm going to do next is I'm going to show you how you can build a beautiful model UI for showcasing how to demo your model. So let me open the next file, and here I have.
Okay.
So just usual stuff, import all the things. I am going to use something called Radio, which is a Python library to build UI directly from Python without coding any React or HTML, CSS, anything at all.
Okay. Cool.
The next new thing that I have imported here is called the serve radio component. To import this, you need to do from lightning run lightning.app.components.serve import serve radio. Lightning has a lot of different components. For example, the serve component, autoscaler component that you can use to scale your API, and you can just connect this to build something big. So what I'm going to do here is I have created a Scikit-Learn serve UI class, which inherits
Okay.
the serve radio
Okay.
class, and I have defined inputs, outputs, and examples.
Okay.
My inputs are the simple width, and height, and all these are numbers. So this is just some Gradio stuff.
Uh
You
huh.
can check the documentation of Gradio if you want to know what this number does.
Yeah.
But plainly speaking, we need a floating point to enter the simple width. So we have used Gradio.number.
Yeah. So these are just widgets so that the user can enter these values, so they can search. Where they can use our decision tree that we've created.
Yes, so these are just so when we define this and when we run this complete application in the UI, we will have multiple input forum with these names, sepal width, sepal length, and we can enter the value there. Click on enter, and I like the way I have defined the server is it will go through the backend and it will classify what does these entered values represent, and
Very
the
cool.
classified value will be presented on the screen.
Okay. Cool. Those are the outputs.
Yeah. So my output is going to be a text. What is the flower type?
Okay.
And I am also going to return the image.
Oh,
So
cool.
if I have a setosa, I'm going to show you image of the setosa.
Cool.
Here I have just entered some examples so that I can just select one of these. I have took this from the test set so that I do not cheat here.
So, and you can use those examples to demonstrate how our app will work. Is that the
Yes.
idea? Okay, cool.
And just usual we have defined the init method, and here again I have the same model storage API.
Mm-hmm.
And what I did last time was I put my model into this shared drive.
Mm-hmm.
Now I'm going to retrieve my model from that shared drive.
Okay.
So the next method we define here is build model. In
Okay.
this build model, we first retrieve our model, self.model storage.get our model file name. It will download the model from our shared drive to the current machine file system.
Cool.
And then we are using the job lib library to load the model, and we just return the model.
I love it.
Next, we have this method called predict.
Okay.
And as the name suggests, we are just going to take all the features, simple width, length from the UI. We are going to make prediction from our model here, model.predict. And finally, we are going to return our class name. And
Oh,
I
an
have loaded
image.
yes, an image. I have loaded the image from the pillow library and just returned it.
Very
After
cool.
you have created all these things, just create the component as usual, create the Lightning app, keep the component inside the Lightning app, and it will create the application for you. So let's run this component, our sweet little command lightning run app, then serve UI.py, which is our file name.
Okay.
Let's launch this on cloud. Awesome.
Bam.
So what this will do is it will take my code, it will publish my code onto cloud and start the machine and just like start executing my code. So let's go to the Lightning AI platform here.
Uh-huh.
I have live stream, logs, and let's see in the work.
Oh,
It is
cool.
currently installing the dependencies from my requirement.txt.
Okay.
And once it is done, it will configure everything and start running my application.
And again, we don't have a setup.py.
Yes.
Okay,
So
cool.
again, we do not have a setup.py.
Yeah.
So meanwhile, let me show you our org. So if you want to learn more about different features of Lightning, what we have done with Lightning, we have a blog page here. And recently we have scaled stable diffusion 3 times. So we went from 6 seconds to 2 seconds. That is just crazy. So we have made a bunch of different optimization tricks like using deep speed, CUDA optimization, and here is the graph of different optimization that we did and the different speed of inference speed that we got. So this particular thing also is open source, so you can just go to our GitHub repository, just check that out, clone it, and launch it on the Lightning AI platform.
Very cool.
Let's come back here. Cool. This is running.
Oh,
Let,
awesome.
let me go to the web UI to see my
So you just click on
demo.
Web UI and it automatically, because we are using Grad.io and those are the inputs that you created. Very cool.
Yes. So these were the inputs that I had created by gr.number. So these
Mm-hmm.
are just some forum.
Mm-hmm.
And I had specified 3 examples. So if I click on any of these, it will automatically populate here.
Oh, look at that.
Yeah. Click on the submit button. It is a Versi color. And here is how it looks.
Oh, I love it. This is amazing. And that was not that hard.
Yes. That was just few lines of code.
No.
And I mean,
And and now you can you've got a URL, you can text it to your best friends and just say, "Hey, check it
yeah.
out. What put in your favorite pedal width and sepal width." And they'll be like, "Oh yeah, let's do this." But it's cool. I mean, it's a simple example, but what I like about it is it's with the nice thing about the Iris data set, it's so simple that we know exactly what it's doing, and now that we know exactly what it's doing, I feel like I have confidence to do more complicated things, right? It's like the hello world of creating a web app or a web ML app. We've like everything we've done, we've verified and we've validated that we're getting exactly what we're expecting. We're getting the right output. Um,
Yeah.
and I think this is so cool. Um, so uh, so it all just sort of comes together. Can we talk a little bit more about how these pieces all came together? Just to give an overview. We don't have to go into details, but just can we just have a summary of how we put everything together?
Did you mean how we put everything together this in this component or just combine everything to build a pipeline?
Well, for the pipeline, so we started off with, we got the data, we
Yeah.
built the model, and then we saved that model. And then once we were done, we sort of turned off that cloud computer because we didn't need it anymore, but because we'd saved that model to that shared persistent resource. And
Yes.
then you created the code for the user interface, and we loaded our saved model from that shared resource, and then all we did was run it from the command line, and it deploys it in the cloud just like here. and the
Yeah.
pieces just kind of come together.
Yes, so let's see. We have created two components and how we can connect all this together to build the whole pipeline.
Let's do it.
Yes, so I have named this pipeline as Lego.
Okay. Oh, I love it. We're coming back to the Legos.
Yes,
Yeah.
so if you see the code is very simple. First thing, I have import Scikit-Learn training component.
Okay.
And this Scikit-Learn training class is exactly what we just created here. So what I have done
Oh, I
is
see.
just,
You named it Scikit-Learn training class. Okay, got it.
yes.
Got it.
So I just imported that.
Yeah.
And similarly, I named my UI thing
Yeah.
Scikit-Learn serve UI. And I
Nice.
just imported it from my module.
Okay.
Then I defined a class called ML pipeline.
Mm-hmm.
And this inherits lightning flow.
Okay.
Unlike last time, which was a lightning work.
Yeah.
So, Lightning Flow manages long running tasks. And by long running tasks, I mean lightning work.
Okay.
So, basically, my ML pipeline is going to manage my sklearn training and sklearn serving. So, the flow is going to manage my works. We define
Very
the init
cool.
method, and inside the init method, I create object for both of my components, the training component and the serving component. Then we define the run method. In the run method, it is just like a flow, how I'm going to execute all my flows. So the first thing I'm going to do is run my training component. So just like plain English, I have run my training component dot run,
Uh-huh.
and I mean it is easier to understand. Like once my component has succeeded, I'm just going to deployment, like run the deployment component. So the API is quite intuitive. Like if you see the code, you try to execute a little bit, play with it, and you can do a lot of crazy stuff with it. Like you can build something great using the framework.
So
Then I have,
so basically, I feel like I'm stepping all over your toes right here, but what I'm thinking is, you know how we just did that summary of all those little bits. You know, we build them, we download the data, we build the model, we create a file from the model, we save the model, we all those little bits. What you've done is you've just streamlined it so that we've just got it in 2 lines of code. And
yes,
this lightning flow is going to take care of everything for us, and we don't have to do it manually. We don't have to like, like the first, we don't have to like manually hit lightning, blah, 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 and do it for each step. We can coordinate it all right here.
yes. So this flow basically coordinates all the different components for us.
Cool. Cool.
And so we have two components, the training and deployment component.
Mm-hmm.
The training job will happen in one machine and the serving job will happen in another machine. So Lightning Flow is just going to take care of launching different machines, terminating these when completed, all of this for us automatically. We do not have to do anything manually.
Love
And
it.
yeah,
I do have
very,
one. I have a Python question. It's not necessarily
yes,
because I'm just going to be honest with everybody. I'm not that good at Python. There's one thing in the code that I'm like, I haven't seen that before. You've got, when you define your run method, on the right side, you've got an arrow to none. What is that? Can you tell me what that is? A little
yes.
Python moment for Josh.
So Python is a loosely typed language, and if you want, you can if you want to make the code readable, you can add type in. So for example, suppose I have something like flower, number of flowers here,
Uh-huh.
and I know that it is an integer. So for others who is going to read my code, I'm going to add a type in, like
Oh,
it is an
nice. Okay.
integer. So I add a colon and int.
Yes.
So this is easier for others to understand, and it is a usually good practice to add type hints. So
Okay.
there are some extensions which also basically can check if your type hints are correct, and
Oh,
Code editors like VS Code
yeah.
predicts automatic suggestions when you like type your code, like what should be next, or like it will automatically color in your editor that you are making some mistake if your code is well, type hinted.
Cool. Okay, I got it now. Thank you very much. That was a nice Python moment for Josh Starmer.
We should do a Python moment with
We
you.
totally should. That'd be awesome because I need to learn. I mean, I'm okay. I just need to learn more, and I'm learning a lot from you just watching what you're doing, which I love.
Oh no,
Uh,
I have learned a lot from you during my college. So I used to watch StatQuest, like I used to binge watch StatQuest channel.
well, I love that I'm learning from you. I feel like the
You are
karma is getting all balanced out. It's great.
you are just too humble, Josh.
well, can we run this? I'm ready to. Can we see the whole thing?
Yes, let's
Oh,
run this in our. We use the same sweet short command, lightning run app, lego.py.
uh huh.
So let's name this something else like Lego pipeline
Uh huh.
and press enter. So this will just like upload my code,
Uh
start the
huh.
machine, and I will be able to see everything. So it will come here
Okay.
in any moment. Okay, here it
Here it
is,
is.
Lego pipeline.
Love it.
And let me go to logs. I have the orchestrator, which is currently pending, waiting for
Mm-hmm.
machine availability, installing all the different stuff from
Mm-hmm.
requirements.txt. So earlier, when we launched our application, the model training had one component, model deployment had one component. In this component, in this application, we have two components. So we
Mm-hmm.
have launched both training and serving at the same time.
Mm-hmm. Maybe at this point, now that we're kind of seeing how everything comes together, can we talk about the question is how is this framework different from Airflow?
Yes, so Airflow is a DAG, and with Lightning Framework, you can also create something like a DAG, but it is much more than a DAG. Like you can deploy an UI with the Lightning AI framework, which I don't think you can do with Airflow. I'm not an expert in Airflow. I have just like read about it. So I don't think so. These are very two different frameworks,
Mm-hmm.
and with the Lightning AI, you can basically create a whole ML ops pipeline. Like you can connect different components like monitoring and different servers. You can deploy even React code on Lightning. So that is what Lightning is.
I mean, I'll be honest. I've never even heard of Airflow before because I live in a cave. Um, but does Airflow like? Do you just do dash dash cloud and stuff automatically runs in the cloud with Airflow, and you have an app that you can then share with your friends? Or
I Last time I tried to run Airflow was I think 2 years ago.
okay,
So I'm not really sure, but I think you need a Docker or something to
uh
run
huh,
this. But
okay,
I'm not really 100% sure about that.
okay.
But with Lightning AI, you can just like pip install Lightning and create the small file, just do lightning run app.py cloud, and it will start executing in your cloud.
Uh, can I just pester you with other viewer comments while
Yes,
we're here?
please.
So another Nishant asked about the data set format. Um, they wanted to know if we could use a JSON file, or is there any particular format? I'm not. Um, yes, can.
Can entire data set send in prediction API any particular format like a JSON file? Yes. So I guess you can use like for training, you can use any kind of format. You just need to convert that into a NumPy array
Mm-hmm.
before you send that into the Scikit-Learn model.
Mm-hmm.
And for using the serving, here we have created an UI, but you
Mm-hmm.
can also launch a REST API with Fast API
Okay.
and or Flask or any model or any serving framework of your choice, and you can hit the API from a JSON or like you can send that as a request body, anything the whatever the way you have created your API.
So it really doesn't, I mean, the file format doesn't matter as long as you've got some functions that allow you to access the data and
Yeah.
convert it into, at least in this example, because we're using Scikit-Learn, we need to create it into a NumPy array. So if we've got tools to do that, who really cares what the file format is? Is that about right?
Yeah, exactly.
One last question. Angel asks, is this the same as Streamlit?
Oh, I guess the question is about the Gradio UI. Streamlit is a different library, but it also is used to create UI using
Mhm.
Python code.
Okay.
So it is just very similar to Streamlit, but not exactly Streamlit.
Could we have swapped out Grad.io with Streamlit if we wanted to? Is that an easy thing to kind of swap out, or?
Yeah, in fact, Lightning has a Streamlit component as well.
Oh, wow.
So if you want to like build something with Streamlit, you can try that as well.
That's super cool. So it's like no pain right there to switch
Yeah.
from, we can do it either way, whichever one we're more familiar with. I love that.
Yes, exactly.
Bam.
Bam.
So is our thing running yet? Can we check it out?
Yeah, our thing is running. So our model has been trained with 97% accuracy. Let's see the
Perfect. Well,
deployment.
almost perfect.
The deployment has also, the serving is also running. So let's go to web UI here.
And this will look the same as before, but it's totally different because now we've combined, all the steps into one, um,
Yeah.
and bundled it
So
together. So if we need to like restart from scratch, we don't have to do each piece independently. We can just run this one lightning flow to take care of everything.
yes, exactly.
Love it.
So just like that, and we have the UI. You can enter anything here and
Hmm.
press submit to see what is the prediction of you from your model. And if you click this button here, you get this URL which you can share with your friends. They
Oh
can
yeah,
open it in their web browser, their phone, and make the model prediction directly on their device.
I love it. This is what I'm going to do for the rest of the day. I'm just going to like check out different irises. I love it.
Yes.
Yeah. Well, Aniket, this is fantastic. I myself learned a lot. It's the code actually looks surprisingly simple. I just love it because, for me, like, if you told me that I had to deploy a machine learning algorithm or deploy a decision tree or something so that people can use it, I would my hands would start to sweat and I'd be really stressed out because I would think I'd have to do a lot of work and a lot of coding and just like, and you've made this look pretty easy, very reasonable. Each little block was like not too much code and I can understand what's going on. And I even learned some Python while we were at it. I just love this.
Yeah, I mean, just like less than even 20 lines of code. So you can like do just crazy stuff.
Mm-hmm.
You can actually we built really cool product with the Lightning framework called Muse.
Uh-huh.
And Muse is basically we deployed stable diffusion there, and with a beautiful funky UI there, you can enter your text prompt and just generate image directly in the web browser.
And so, yeah, so we can scale this up to be as fancy and complicated as we want. So we've done the most simple thing. We've done the hello world of building a decision tree. And what I like about that is we can validate that everything's working as expected. But now that we've got that in place, we can start doing state of the art stuff. We can put stable diffusion so we can like create crazy pictures of cats jumping off of flying saucers into a pot of, spaghetti. And we could, it'll generate that image for us. So we can these little things that we did, just it's super simple, but we can, now that we know how to do it and we can trust that it works, and we know, we've experimented with running things on the cloud, and we're like, oh great, we can take the same exact steps to build and deploy the state of the art sort of in artificial intelligence right now, which I think is super cool.
Yeah, it is amazing. And if you are training a state of the art model, you might need to do like train models on distributed platform.
Mm-hmm.
So Lightning also provide components which
Yeah.
you can use to train your model in a distributed fashion on multiple nodes.
Okay.
And you do not need to configure any machine or anything. You just need to import a multi-node component. So that is really cool and handy for any machine learning engineer.
That's very cool. So what you're saying is that rather than having to worry about all that infrastructure and like how to configure all those machines or even how to distribute stuff, I can just import this one component and it'll take care of those details for me, is what you're saying.
Yeah, exactly.
Awesome. I love it.
Cool. So I think we have one more question. Oh, I think it is for you, Josh.
Someone bought the Kindle, but they need the PDF copy. How do you get a PDF copy? It's a good question. I don't know. Um, I mean, other than buying the PDF copy, I think that's really the only option right now, which is unfortunate. I wish there was some way to bundle it, but because they're sold by different entities, it's not easy to just bundle these things. So I wish I could. But thank you for your support. Yeah, I wish I could do some sort of like, all access pass to the StatQuest library. But that's maybe that's something we'll do in the future.
Awesome.
Also, I just want people to know that if you obviously this is live, but it's not going away. If you want to review this, you can. There'll be a URL available immediately after the live, so you can take this URL, you can watch it yourself, you can text it to your friends, so they can watch it too. And I believe Aniket, but I'm not certain. But I believe this code is also available, and that instead of having to write it all ourselves and squint at the computer screen and make sure we're typing in exactly what you typed, that we can just download it. Is that correct?
Yeah, exactly. So this code is available on GitHub, and let me share it with everyone else.
Yeah, let's do it. So yeah, you can watch the video and you can download the code. And also, just to let you know, we're gonna put this. Lightning has a cool blog with cool stuff that includes the occasional StatQuest entry. But we're gonna have this video and the link to this and the link to the code will be on the Lightning AI blog. So check that out. So yeah, so there you go. Bam.
Bam. So we are going to do much more of these kind of sessions,
Yeah.
and uh, please fill the feedback form. Let us know what you'd like to learn from us in the next live stream. So see you next time.
Yeah, see you next time. And actually, because I can't let people go without a triple bam. Let's do a quick summary. We created a Lightning work to uh, load the data and train the model. Bam. We created a
Bam.
Lightning work to create the user interface and use the model. Double bam.
Bam.
And then we created a Lightning flow to put it all together into one, big thing that could be deployed easily. Triple bam.
Triple bam.
I love it. Super awesome. Well, thank you very much, Aniket. I learned a ton, and I hope everyone had a good time today. And until next time,
Thank you
lightning
so much, Josh.
on. Yeah,
Have a
thank you,
great
man.
day.